Hello everyone, thank you for allowing me to present at the 7th International Conference on Industrial, Mechanical, Electrical and Chemical Engineering this time. First of all, let me introduce ourselves. I am Anastasia Devina with my colleague Elisa Fitriyani from Chemical Engineering 11 Maret University, Surakarta. Today we will present about microencapsulation of rice bran oil by complex coacervation using Chitosan, Carrageenan, influence of amount of cross-linking agents. So let's start now. First, we will discuss the origin of rice bran oil. According to data from the Ministry of Agriculture in 2004, rice production reached 31.8 million tons, which gives rice bran about 3.18 million tons. The rice will be processed into rice through the rice milling process. The milling process will be produced waste in the form of bran, which can be used as a source of oil. Bran oil has many benefits, so it is widely used by people in various fields. Besides disadvantages, rice bran oil also has disadvantages such as being unstable and susceptible to oxidative damage. It is necessary to find a way to maintain its biological and functional characteristics, one of which is microencapsulation technology. In the microencapsulation process, used material that function as cross-linking agents, we use glutaraldehyde. In this research, the influence of the cross-linking agent, i.e. glutaraldehyde, on the characteristic of product, yield, and encapsulation efficiency were studied. This research has several objectives. The first is to investigate the effect of adding glutaraldehyde as a cross-linking agent. The second goal is to produce microcapsules with micro size and round, and the last goal is produce microcapsule with high encapsulation efficiency. The material needed in the research are rice bran oil, Carrageenan, Chitosan, 220, glutaraldehyde, and then glacial acetic acid, sodium acetate, ethanol, hexane, and aqueous. This method consists of three steps: preparation of solution A, preparation of solution Chitosan, and microencapsulation process. Preparing solution A. Solution A was prepared by dissolving 0.3 of Carrageenan in a 100 ml of buffer solution at stirrer of 250 rpm. Stirring is continued for 15 minutes while adding 0.5 ml of rice bran oil and 0.5 ml of 220. Preparing solution Chitosan. Chitosan solution was made from dissolving 0.3 gram of Chitosan in 100 ml of buffer solution, pH 4.6, accompanied by stirring at 260 rpm. The last step is microencapsulation process. Into the Chitosan solution, solution A is added by dropping to obtain the polyelectrolyte complexation. The system temperature is increased to 70 degrees Celsius, and stirring is continued until it runs from 1.5 hours. After stirring from 1.5 hours, glutaraldehyde was added to the polyelectrolyte complex, and the system temperature was lowered to 15 degrees Celsius. Stirring continued until it ran from 3 hours. After 3 hours, the system temperature was raised to 50 degrees Celsius. And then, the solid is separated from the liquid by filtering. The solid is washed with water, then with hexane and ethanol 96%. The particles are dried from 12 hours at 50 degrees Celsius and from a rice bran oil microencapsule. Next, we will discuss about yield. Yields are used to determine the efficiency and effectiveness of a process. The yield value is calculated using the following formula. The yield is equal to the weight of the microcapsules divided by the weight of the microcapsule forming multiplied by 100%, which can be seen on the following slide. In this research that we have done, we analyzed the samples with different amounts of glutaraldehyde added in the microencapsulation process. The amount of glutaraldehyde added was 0.25 milliliters for the first sample and 0.5 milliliters for the second sample. By using the yield calculation formula on the previous slide, the yield value for sample 1 is 95.3402% and sample 2 is 81.5608%. Okay, now we discuss the results of the characterization test using the FTIR. As is well known, FTIR is a tool used to determine the functional groups present in the sample. The results of the FTIR test of our sample in the form of spectra can be seen in the image shown on the slide, where image A is rice bran oil, image B is Carrageenan, image C is Chitosan, image D is microencapsulation in the sample with the addition of 0.5 milliliters of glyceraldehyde, and image E is microencapsulation of sample with the addition of 0.25 milliliters of glyceraldehyde. Rice bran oil show interaction between the amine and sulfate groups Chitosan and Carrageenan success in forming complex polyelectrolytes. The microencapsulation rice bran oil FTIR spectrum shows peak in 2919 and 2923 to the power of 1. The peak indicates the presence of rice bran oil in the microcapsule.
Scanning electron microscopic or SEM analysis from microencapsulation of rice bran oil 0.5 ml with a Carrageenan coating, Chitosan coating, and twin 20 emulsifier with variation of glyceraldehyde 0.25 ml and 0.5 ml are shown in slide. The SEM image shows that the morphology of microcapsule is not round and has a round surface. Different appearances were obtained in both samples due to the effect of coacervation technique performed to form a combination of particular structure. Microcapsule with higher amount of glyceraldehyde has a crosslinking and can give a bigger particle. The microcapsule walls become compact, a degree of crosslinking increases, resulting in smaller particles. Encapsulation efficiency can be known by performing microcapsule rice bran oil extraction first. This test aims to calculate the volume of oil successfully encapsulated in the rice bran oil coating process using Chitosan and Carrageenan polymers. The encapsulation efficiency were calculated by the following relationship: weight of oil encapsulation divided weight of oil added from encapsulation times 100%. It can be seen from the table from the variation of the amount of glyceraldehyde study, encapsulation efficiency decreases increase in glyceraldehyde. The highest encapsulation efficiency was found in the first with an encapsulation efficiency of 55.48%, followed by the second sample with an encapsulation efficiency of 54.08%. Increased amount of glyceraldehyde can harder particles, resulting in low oil absorption. Based on the result of experiment, it can be concluded that the result microcapsules are micro-sized, they are not round and have an uneven surface. But with the increase of glyceraldehyde, the surface of the result microcapsule will be smoother. The addition of glyceraldehyde volume as a cross-linking agent leads to decrease in encapsulation efficiency. The highest encapsulation efficiency occurred on the addition of glyceraldehyde by 0.25 ml by 55.48%. An increase in the amount of glyceraldehyde can cause particles to be stiff and decrease the absorption rate of the oil to be ignited. And then bring us to the end. I would like to thank you for your time and attention today. See you next time.